Hi, I'm Dan Lynch, and you can join myself and Aaron Newcomb on FLOSS Weekly this week, where we talk to Dan Walsh from Red Hat about SELinux, a security layer which sits on top of Linux. That's coming up next on FLOSS Weekly.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by Cachefly at CACHEFLY.com.
This is FLOSS Weekly, number 156, recorded March the 9th, 2011. SELinux. It's time for FLOSS Weekly, the show about free, libre, open source software. I'm your host for today. My name's Dan Lynch, and as you will probably be able to tell by my voice, I'm not Randall Schwartz, who's your regular host. He's away cruising at the moment, but he'll be back next week and in charge again. So I've kind of made a little takeover this week, and I'm pleased to say I'm joined by fellow co-host Aaron Newcomb, all the way from the Twit Cottage today. How's it going?
Whoops! I lost my mic. There I am. Hey, very good. No,
okay.
it's real good. It's a nice morning here in California. Nice cool morning. So it's good to be here.
Excellent. And the topic on the slate today is SELinux, which is a hardened security layer for Linux systems, predictably from the name, and it enables you to get really kind of fine-grained control over what your applications are doing, what your processes are doing, and obviously what your users are doing, which is very important in security, and all that kind of stuff. And I'm delighted to say we're going to be joined by Dan Walsh, who works for Red Hat. And he's the lead developer of SELinux, which has been around quite a while, has some links to the NSA, which I'm curious to find out more about because, all these kind of secret service things always intrigue me. And I think that'll be very interesting. So should we get into it? Get right into it then?
Yeah, absolutely. Let's get going because I've always had a lot of questions about why SELinux is so important and why it keeps popping up on Red Hat and Fedora so often. So this will be a really interesting conversation.
Okay, so let's bring on our guest for today. We're joined by Dan Walsh, who works at Red Hat, and he works on SELinux. So how are you doing, Dan?
Great.
Yeah, so where are we speaking to you from?
I'm at my house in a town called Marlborough outside of Boston, Massachusetts.
Oh, nice. I like your wallpaper there. I'm enjoying your wallpaper and decorative plates behind you. That's very cool. One of the things about doing this show is we get to see people's houses. We get to kind of check out people's houses as we do the show. So I gave a brief introduction to SELinux and explanation of what it is at the start of the show. But to be honest, there's no one better to explain it than yourself, I presume. So can we start off by giving us a little bit of a background on SELinux, on what it is and where it came from and so on?
Right. Well, the history of SELinux is it was developed out of National Security Agency the fundamental thing you have to understand about the National Security Agency is there's two parts of it. There's the part that goes out and gathers information, and then there's another part that tries to prevent other people from gathering too much information from the United States. So the part that does that developed secure, more safe, so they developed a architecture called SELinux probably about 15 years ago, and they wanted to basically make that into something that could secure all computers in the United States and other of our partners or allies. So they decided to do an open source project, and they worked with Red Hat and other people in the open source community to get this stuff out. The fundamental thing to understand about SELinux is it's a labeling system. And if you just think in terms of labels, there's labels on all processes on the computer, and there's labels on all files on the computer. And then there's a whole bunch of rules about how the labels interact with the files, or all objects on the system. And if you just always think of, I have a process that's labeled A and a file that's labeled B, and then I have a whole bunch of access rules that might be between the two objects. When things go wrong with that SELinux system, it tends to be something wrong with your labeling. I have a couple of papers I wrote trying to describe this, but if we get people to understand at that fundamental level that either the process is labeled incorrectly or the file is labeled incorrectly, that might be what's causing your SELinux problems. when SELinux is working well, it's basically setting up an individual process that can only access.
Nope. I think you may have just
Apache server can only access, for example, Apache content and not be able to access a database content or not be able to access secret files in your home directory.
So it sounds as if it's a bit like sandboxing things to keep to keep them safe and to keep other things safe from what they're doing. Is that a fair reflection in any way?
Yeah, I mean, actually, there's a product called the SELinux Sandbox that's
okay. So there you go.
Later on, but not to confuse things. But yeah, I mean, you can think of it as, Sun has a product called containers and or virtualization. They're all different ways of doing, or all similar goals in these products is to take an application and make the application only able to do what it was designed to do or what it's supposed to be doing, so that if there's a bug in the application can't go off and do something bad on the system. So SELinux gives you incredible flexibility. So you can do things like set up an Apache server that the only way it can talk to the database is through a named port. Even if there was a vulnerability in the Apache server that could get it to run as root, it wouldn't be able to touch other locations on your operating system and just be able to talk to the say the name pipe that talk to MySQL. And so we can get down to fundamental levels. We can differentiate files, but we can differentiate access. We can basically allow append access to a file versus write access to files, things like that. So it's at a fine-grained level. The other thing SELinux can do is control network access and port access. So I can basically set up an Apache server that can only listen on port 80, and even if it got taken over, it wouldn't be able to become a mail spammer or something like that, because it wouldn't be allowed to connect to the mail ports.
So it's giving you much more granular control over security, effectively, on your Linux system. Yep.
Yeah, basically, and we tend to, the policy distribution more so than by individual operators. And the main reason for that is because operators tend to want to make their applications work. So if you were writing policy for your application, most people say, well, my application could be set up to read anywhere or write anywhere, could be set up to listen to different ports, things like that. So operators tend to write what we call unconfined policy. Whereas we want to write sort of the default way you configure your system is we want to write policy that says the system can only work the default way. And if you want to change the default way you run your system, then you have to work with SELinux and tell SELinux you're going to change the defaults. So we try to write and do things in secure. For instance, Apache can, some people set up Apache to be able to send mail, but most people don't. So out of the box, Apache's not allowed to send mail. Similar, people like to change the port that SSHD listens on, and if you want to change that port, you have to tell SELinux about it. There's commands to tell SELinux that you're going to have SSHD listening on a different port than port 22.
I was interested about the NSA involvement. I don't know how much you can say about that, but there was one of the kind of long-standing things that I'd always heard about SELinux was that there was a lot of involvement with the NSA, which is the National Security Agency over in the US there. So I think you actually said it was them who came up with the idea of starting the project, so it didn't come out of Red Hat or somewhere else, it was out of their need for it, is that right?
It was, the researchers worked for the NSA that originally developed the ideas. If you really went back on the ideas actually came out from the 1970s, the idea of trusted computing. And back in the 1970s, trusted computing was, they developed three basic concepts. One of them was called the Bella-Padula model, and that tends to deal with data at levels. So you have top secret data, and then you have rules about how a top secret process cannot write to a secret process. A secret process can't read top secret data. That's one form of mandatory access control. Another form was a thing called role-based access control, which is when I'm running at one role, I can run certain processes and read certain data, and then if I want to run different processes or different applications, I have to switch my role, and that's called role-based access control. The third one was a thing called type enforcement, and SELinux fundamentally is based on type enforcement. The other two types of mandatory access control, and I didn't define what mandatory access control. I'm sorry about that, but the mandatory access control means that the kernel makes all decisions on access. Is not allowed to the individual process to decide. And called discretionary access control, which means that the process has discretion over all files that it owns. And so a process can change the permissions on a file, for instance. So if you ran Firefox has the ability to change permission on all files that you own. In a mandatory access system, you have rules that the kernel is going to govern. So the kernel looks in and governs what access decisions can be made. So the third type of mandatory access control that was defined in the 70s was a thing called type enforcement. And type enforcement governed more on the type of the application or the type of the process. So if you think of an Apache process or a MySQL process or a user process, then you write rules about how that type can interact with other types, the types of the file. So that this is a Apache content, or this is a MySQL database, or this is a file in a user's home directory. And so type enforcement was never developed until the NSA took the ideas and they developed SELinux around type enforcement. Now, over the years, we've worked with the NSA to further develop the type enforcement features, and we've actually built out the RBAC, role-based access control, and we have MLS or Bella-Padula model. So now we have different forms of policy depending on how you want to run your system. So back in when RHEL 5 came out, we actually have an MLS system that can be used on the highest level security systems in the world, and with the exact same kernel, exact same code base we can run on my father's laptop and at his house. So we can run different types of policies and different types of rules depending on your security goals of where you're going to have your computer system. Now that's different than say what Trusted Solaris had, which was there was a special operating system called Trusted Solaris. So in a SELinux, people think there is a SELinux system, but SELinux is just part of Fedora or part of RHEL. And actually SELinux is also available on Debian, Ubuntu, Gentoo, and a few other Linux distributions.
That's something I was actually going to ask you about, because obviously I know you work for Red Hat, and I know that from experience of using Fedora and other things that SELinux always comes with it. But I was curious about how easy it is to use on other systems, say Debian, as you mentioned, or Ubuntu, or whatever it might be. Presumably that's a third-party packaging effort. Do you concentrate on Red Hat platform and so on, and let other people deal with packaging it for Debian or integrating it with Debian?
Yeah, I mean, I help out other distributions when they have problems and stuff. But obviously, I'm funded to work on. Most of my work is done on Fedora and even on Rawhide, which is the daily Fedora. But I work with the community. I work with the people that are doing the ports to Ubuntu and to SUSE and other platforms. I also, obviously, we take everything we do and work to get it upstream so that we benefit all the distributions. And by the same token, we get benefits when other distributions do effort. So it's just standard community work. As far as getting SELinux onto the other distributions, it doesn't come by default like it does in Fedora and RHEL. So you have to download it. Download special packages. I think there's a special distribution Gentoo called Gentoo Hardened, and I forget Ubuntu version. But there's some pretty strong community leaders working on SELinux on the other platforms as well.
So this kind of brings me up to kind of some questions that I had about SELinux. I mean, let's back up just a little bit and explain for people who may not have run Red Hat versions or Fedora what this looks like. How does it get presented to the user when they're installing Red Hat? You mentioned that on the other systems it's packaged. You have to purposefully install it. But on Red Hat and Fedora, how is SELinux presented? How does it get installed?
Basically, it's just there. It's not, you have to actively work to get it turned off. I would equate it to sort of like the way we run firewalls. And that, the goal of SELinux and the goal of firewalls is that they don't get in the face of the average user. That's what our goal is. And SELinux tends to have more problems with sort of advanced admins that like to change everything the way everything works in the system. So out of the box, the SELinux experience should be that you don't even know SELinux is running it. And actually, if you look at SMOLT numbers, which are numbers we gather of how people run Fedora systems, it's somewhere above 70% of the people run with SELinux in enforcing mode. The system's locked down with it out of the box. It's not so much that you would even see it unless you tried to change the basic configuration of, say, the Apache system worked or other parts of the system. Now, user accounts, by default, we log in users with what we call unconfined mode, which means that a user can do anything they want on the computer system out of the box. We have confined users, which allows you to sort of lock down users on the computer system to different levels. But out of the box, we run with the unconfined users. So users that log into a computer system directly have the ability to pretty much do what they could do disabled. It's more that we lock down the other processes on the computer system, usually the network-based network listening processes on the computer system.
Right, and it's been a little while since I've run Red Hat. I mean, is this still presented on install? Do you still get presented with an SELinux configuration screen on install?
No, that's it. I think in RHEL 5 we still present the ability to turn it off, but in an effort to simplify the installation procedure over the years in Fedora, we've turned off lots of to configure during the install. So right now you have to go in after the install and turn off SELinux if you wanted to disable it. Or I mean, you could also do it via Kickstart. So if you were doing a Kickstart install, you can disable it. But yeah, there's no screen that comes up and tells you. We do have a tool called SE Troubleshoot that when something happens on the system that SELinux blocks or notices, a little icon will appear in the top of the screen to tell you that SELinux did something. And if you click on the icon, it will try to describe what SELinux blocked and it tries to figure out how to fix, tries to figure out what happened and mechanisms to fix it. So the idea would be if you decided to change Apache to listen to port 8081 and you ran Apache and SELinux said that's not allowed, this little tool would come up and say, hey, we know to listen on port 8081. Here's the SELinux commands to allow that to happen. If you didn't intend to listen on port 8081, then you might have something going very strange on your computer system. You might want to look further into it.
Right.
And that's a tool called SE Troubleshoot.
So you've been working on this since the beginning, right? I mean, you've been working on this for since the early days of Red Hat, correct?
Yeah, I joined Red Hat in basically 2001, and I started working on SELinux in 2002. The first time SELinux, I actually worked with SELinux and Fedora Core. And SELinux actually first showed up on in Fedora Core 3, and frankly, it was pretty rough at that time. Matter of fact, even through RHEL 4, SELinux, we were just learning how to deal with this thing, and Over the years, SELinux has gotten better and better, and I don't believe that you could have done a thing like SELinux without having, open source and the ability to, work with the community and my Fedora testers and things like that. Because we really, its policy has sort of evolved, the way applications work, and the understanding has worked. But yeah, I've been working on SELinux now for about 8 years.
And when you started working on it, I mean, I know you talked about the NSA's involvement and some concerns that they had. But when you started working on it, were you new to security, or was this something that you'd have been working on a long time, but previously to this?
Well, my history is I actually worked on sort of security products for the last 25 years. I worked on the Alta Vista project back at Digital time, and I was working on tunneling and firewall products back then. I've also worked on intrusion detection systems with companies called BindView and NetTech that all ended up getting bought out by Symantec. So I've been working in security-based products for many years. This is the first time I worked in sort of trusted computing or mandatory access control type computing. Was after I came to Red Hat.
Right. So here's a question then. I mean, just given your history on this, I'm kind of curious. I've always wondered about this, and that is why. So as a user of Fedora and Red Hat for a long time, it always kind of bothered me that SELinux was presented when it seemed to be more geared towards, server environments or, special security situations. And I guess I'm kind of curious, was there a backlash a little bit against all the viruses that were coming into the Windows space, the Microsoft space? Was it kind of seen as, hey, we need to jump on this so that we don't end up in the same situation that Microsoft is? Because at the time, of course, they've gotten better, but Microsoft, especially Windows, was ridden with viruses and all kinds of stuff back in the day. So I'm just kind of curious, was there a little bit of a concern at that point to say, look, we need to get ahead of this in the Linux space before we end up in the same situation as Microsoft?
Yeah, I mean, I sort of explained at the beginning of the talk about why, the NSA was developed this, but, I never really explained why Red Hat, wanted to invest so heavily in SELinux. And what you explained is sort of, the main goal was to, RHEL and Red Hat products, we like to think of ourselves, and we like to advertise ourselves as being much more secure than the competition. What we want to do is we always invest in making, increasing the security of Linux. And if you look at Red Hat's history and the development, the things we've added to firewall, IP tables, things around, making glibc more secure. Lots and lots of effort. Red Hat spends a lot of money to try to make Linux the safest and most secure operating system out there, and the SELinux system just followed on to that. So the SELinux was most of RHEL's money is made on the server end. So SELinux came in to help make the server side more secure. But we also always had the goal to make the client experience more secure, and leads me to some of the new technology we have now. I don't know if you've seen it, but we have a tool called the SELinux Sandbox, which allows you to run desktop applications under total lockdown mode. So one example is, say you want to run multiple versions of Firefox and you wanted to secure, have say Firefox that goes to your online banking be separated from Firefox that goes to sort of the random sites you go on the internet. Well, you can set that up with SELinux Sandbox. You can run full desktop environments where the desktop environments can't talk to each other, and that's at the choice of the user. One of the things I do inside of my, one of the things you have to worry about download sort of untrusted content from the internet. So you download a PDF or a .doc file from the internet, and you want to basically view and maybe print that document. Well, when you download that document can cause, say, your Acro Read or your events to go off and do evil things on your desktop. What I set up is Sandbox events to look at PDFs, and it runs a sort of a totally separate desktop environment where I can view my the PDF that I downloaded, but the PDF can't touch anything in my home directory. It can't talk to the network. It can't do anything except display inside of its own X window its content and allow me to print from it. So you can start moving towards the desktop environment and building tools that people can build more and more secure desktops. So yeah, the main goal with SELinux is obviously to increase the security, and that's of the entire operating system.
Right.
As we move forward now with SELinux, we're looking at more and more having more and more processes running their system with sort of the exact same rights, except they want them totally isolated. And the main one that people talk about now is virtualization. So if you run 10 virtual machines inside of your, say, your desktop or inside, you want all those virtual machines to have the same, same type. But you want to make sure those virtual machines can't talk to each other through anything but the network, right? You don't want a virtual machine being able to break out of its confinement or break out of the hypervisor and able to attack other virtual machines. So we've developed a thing called SVirt, which is secure virtualization. And what that's really using is SELinux for isolation. So now when you run a Fedora platform or a RHEL platform, run our virtualization suite, we're using SELinux to make sure all the virtual machines can't talk to each other. So the only way they can talk to each other is through the network. Sandbox, the SELinux Sandbox is using the same idea that you might run 5 different Firefoxes, and you want to make sure that none of those Firefoxes can talk to the other Firefox processes. So we're looking at how can we isolate individual multiple processes that all pretty much have the same type of access rights from each other.
So does Sandbox run at the hypervisor layer then, or is there a way to run?
No. Sandbox is running below this. Sandbox is more at the process level. So an SELinux Sandbox or the X Windows Sandbox actually launches off a new version of Zephyr using namespacing to create overrides a temp, and then sets up a full user environment inside of its little Zephyr window. So you could think of it as being a sort of a low level virtualization or an application virtualization environment, in that it's getting its own home directory, its own temp directory, its own X Windows server, and using SELinux to confine what that process is able to do. Now, from the user's point of view, it looks just like a normal application running on the desktop. It's just that application is does not see the rest of the desktop. It only sees its own sort of window or virtualized world. With SVirt is doing similar technology, but in this case we're doing it at the QEMU level. So we're taking each one of the QEMU processes and putting labels on it and making sure the QEMU process, one QEMU process can only talk to its virtual image. It can't talk to other people's virtual image. And we're using, that's the thing called SVirt. Same basic technology, or the SELinux is very similar between the two. But it's one's using KVM and virtualization, the other one's using this is sort of the standard Linux tools that are available, things like unsharing and mounting and using additional X servers.
Right. Okay. So one more question for you, and that is, since we've got in the Linux community in general, since we have obviously Red Hat and Fedora are using SELinux by default, and I don't believe that many of the other distributions are using it by default, although it's available. I'm just wondering, have you seen, or are you aware of, is it the case that the other distributions are being compromised more often, or have more vulnerabilities, and people are taking advantages of that? I mean, do you see that, or is there evidence of that, or are we protecting ourselves against a threat that isn't actually out there?
I mean, I'm not familiar with. There's some sites that list all the vulnerabilities that SELinux has blocked over the years, and I've never gone and looked to see if other people's. I mean, these are Linux vulnerabilities. Ubuntu and SUSE adopted a package called AppArmor, and they as their default, although I believe they have it turned off by default or have a very limited amount of coverage. So I've never looked to see if their default mandatory access system would block the same type of access that SELinux has blocked in the past. I think overall Linux is more secure. I mean, there's two reasons, a number of vulnerabilities. Well, I shouldn't say there's two reasons, multiple reasons that Linux doesn't have the vulnerabilities of, say, Windows. And one is just the sheer volume of Windows. It's like the old line about, why do you run money as well? There's so many thousands, millions of desktops running Windows, so that's where the viruses and attack routes go against. The second issue is, obviously Linux is, because it's open source, the many eyes idea that, many people examine the code and therefore it runs, it's more secure because of that. Lastly would be, I would say that the Unix model tends to be more secure than the Windows model, just from their history. But, SELinux blocks certain types of access, certain types of attacks. It's like AppArmor can't block. So it's every layer of the computer system makes the computer more secure. I don't think Linux is exactly hugely vulnerable with SELinux turned off, but I look at security through layers, right? I run firewalls, I run SELinux, I run in my house we don't have any Windows boxes running anymore, even though I have teenage children. They all run Linux because I want as secure a system as possible.
And something that I imagine a lot of BSD fans will be screaming right now is what about BSD? I know your product's called SELinux and you're focusing on the Linux side, but I heard recently that the FBI and some other agencies in the US were pushing things like OpenBSD. Have you had any interaction with any of those groups at all? And you mentioned the Unix model. Obviously, they have a slightly similar Unix model.
There's. Well, first of all, there is an SELinux port for BSD as well.
Okay.
But most of our major, the customers I deal with the most often tend to be people in the Department of Defense and FBI and things like that are obviously using SELinux quite heavily. So, there's good in having diversity of operating system, and each. The nice thing about Linux is in my belief, is that we take the best ideas from different operating systems and put them into Linux, especially towards security. So BSD has some nice features that they've added, I don't know what else to say about that.
No, that's cool. I knew there'd be people out there wanting to know about that, so I had to get that one in. And speaking of people out there wanting to know things, we've got our IRC channel running at the moment, and there are people asking questions in there, so I've kept them waiting long enough, so I think I'd better get to some of the listener questions. Okay, so we have a question from Troubled, who asks, how does this compare in features and auditing abilities to something like Grsecurity? Any ideas on that?
Well, it's Grsecurity works on different levels. Grsecurity is trying to further secure the kernel and does different types of things. So I believe that some of the features of Grsecurity has never gotten accepted into the upstream kernel. So that's sort of a fundamental problem with it. Grsecurity, one of the things about SELinux is SELinux relies on the kernel for enforcement, and what the Grsecurity people would say is that a vulnerability in the kernel, potentially would allow you to, subvert an SELinux system. And we've actually had vulnerabilities in the kernel that, have allowed people to get by SELinux. And Grsecurity is their goal is to to sort of compartmentalize the kernel itself, and sort of like what the old Mac guys were doing as far as trying to break apart the security, break down the security of the kernel, so the different the kernel runs at different levels and things like that. But again, the Grsecurity patches have never gotten into the upstream kernel, and for whatever reason, and we would love to have some of those ideas moved into the kernel, and hopefully eventually some of the better ideas will get into it.
Another quick question from the IRC channel is do you have any idea how much overhead this adds to your running SELinux would add to your typical system? Is there any performance overhead to be taken into account with this?
Yeah, I've been answering that question for years, and
Right.
there is no great answer. We used to always say 5% overhead, and a lot of those numbers are made up. When we've done tests, depending on your workload, we've seen you can make a very, very horrible test that makes SELinux perform at 10 to 15% overhead, but for most general tests, it's in the weeds. You can't even tell what's happening. What SELinux does is when it makes an access check, it looks it up once in the so say you read a file off of a system, when you open the file to read that access checked, whether the process labeled A can read file labeled B, that gets stored in an access cache. And now from then on, every time you further read that file, it's just hitting the cache constantly. So there's so much caching put into SELinux that there isn't a big overhead put on the system. Now in certain workloads, you might be able to figure out some horrible workload that with SELinux would come into be a problem. But really we're talking about CPU here, and most systems the CPU is you have totally way underutilizing of the CPU on the computer, on modern computer systems. So I don't think I would just say test with SELinux and test without it. I don't customers that are using SELinux tend to be, we have Wall Street customers using it, and obviously they need, incredible throughputs, and SELinux does not give them a problem in those systems. Large banks, obviously Department of Defense, people that are really into performance use SELinux, so I don't think it's a big problem.
And I suppose this is probably another question that you get asked quite a lot, but one of the things I hear most from other Linux users in relation to SELinux is, when they come to use it on their home desktop or something, a lot of people find it very confusing. Is it really aimed at the home desktop? Do people need to use it on the home desktop? And how can you make it easier, or how have you made it easier for people to understand?
SELinux obviously has evolved over the years. So, and one of the sad things is that people that used SELinux 4, 5, 6 years ago, got an opinion of it and have sort of stuck to that opinion, and so I would just say that most users never even in that way. As I said, the people that tend to have the people that have the biggest problem with SELinux are people that do development type things. Kernel developers have traditionally had problems with it because they're always installing new kernels, and then they screw up their labeling in the system, and SELinux starts complaining. But for a home user, that's usually what I would call a home user is someone that just gets on a computer and uses it to access the web, and SELinux would never get in the way of that type of person. Where it gets in the way of is just, if you're running a service or certain types of, wacky environments. What we have done in the past is try to make sort of the unconfined user more confined, and occasionally in Fedora we've made mistakes, or people have downloaded bad applications. Right? And one of I've tried to prevent is sort of buffer overflow memory attacks, and there's a bunch of checks to look at. A system that we think is having a buffer overflow attack. The problem is that there's lots and lots of badly written applications out there, and usually they tend to be closed-sourced code, say like NVIDIA drivers and things like that, that do these executable memory. Executable memory is memory that's both writable and executable at the same time. And if you do a buffer overflow, would be to write to a portion of memory that, and then execute the code that you wrote into it. And so the checks that SELinux has put into place for those have sometimes caused some of these applications to blow up. And that would tend to be the only time that a normal user, would get hit by these types of problems. But a lot of those checks we've actually decided to turn off over the years, because it's very difficult to take a system like SELinux and make it work for everybody.
I suppose that one-size-fits-all thing doesn't really apply in this case, does it?
Right.
It's very difficult. You never know what each person's going to do with their system at any time. I mean, it's one thing I hear quite a lot from people with desktops and stuff is how do they just disable it? That must be really annoying for you when you put a lot of work into something and then people just switch it off. Does that ever get to you?
No. Matter of fact, when people say that to me, I use it's the same people that also believe that there's sort of a hubris of Unix people out there that think that they totally understand how computer systems work, and they write in their machine in such a secure way that they are invulnerable to attack. And for those, if you believe that you totally run your environment in a totally secure manner, then go ahead, turn it off. Again, I tend to believe that in security and layers. What I do find funny is that people is that difficult, and yet I see it as fairly simple. Obviously, I've been working on it forever, but there's lots and lots of information out there. There's lots of people that are willing to help you, to fix the problem. The problems that SELinux will get in. I actually blog quite heavily on a site called danwalsh.livejournal.com, and I've actually written blogs over the years talking about the fight between security and usability, and even though we get more and more good ideas around making things secure, it always ends up distributions and things like that end up turning them off by default. So, for instance, when Solaris came up with the idea of compartmentalized, environments, they turned it off by default, or Ubuntu shipping with their security layers turned off. And the reason for this is because people feel security is hard and makes the system more difficult to use, but so how do you end up making security easier is to actually turn it on and figure out how to make the system work. What can we do to make security easy for the user? How can you educate the user? And that's sort of what we've been working on all these years with SELinux. And we were successful in some degrees, we haven't. I think one of the things, at least in the last couple of years, I've been trying to do is to get technology into the, a lot of the people say, well, SELinux doesn't protect, the user account, and no, it doesn't protect, me logged on the system, so why do I have it? Well, what people don't understand is when they're running a desktop box, they have a service called Avahi running in the background, or they have a service, SSSD running in the background, and all these other system-based services running on the system, and you're vulnerable to attacks through those routes. So SELinux, even on a desktop system, is potentially protecting a bug in Avahi from taking over your computer, or a bug in SSHD and other services from attacking your computer.
Yeah, I mean, it's a difficult subject because, as you say, I think one of the key rules in security is anybody who thinks they're beyond attack or completely secure is riding for a fall, as they say. It's always a difficult thing. One thing I was curious about, kind of on an organizational level almost, is how many people actually work on SELinux, because I know you work for Red Hat and you work on SELinux. Is there anybody else working on it there?
Yeah, we have full-time employees that work on SELinux and Red Hat are really just 4 of us. There's 2 kernel engineers, Eric Paris and James Morris, and myself and Miroslav Greppel work on policy. But in one form or another, we did the original for the secure virtualization, but now the virtualization teams all handle the SELinux work on that. We work with the IPA teams, other teams inside of Red Hat. For instance, System D, which is the new booting system that's coming in. Fedora Core 15 is lots and lots of SELinux intelligence built into that, and so we've worked with the the developers of that to put the SELinux controls in that. You have tools like UDEV that have to do labeling and other RPM. So lots and lots of people inside of Red Hat do SELinux work. If not every day, but they do it fairly regularly. They have to understand how the SELinux system works. Plus QA, we have a rule inside of Red Hat that no products can, any of the test suites that run have to be checked to see if they generate an SELinux error message when they ran, and they, we will not ship a update to RHEL that that can have all its tests run without an SELinux error happening. So it's high. So it's 4 full-time SELinux people, and then. Okay. The company.
Does anybody from outside work on it? I mean, I imagine that's something that intrigued me about this, with it being such a core security product that obviously it's an open source product, but can you realistically take patches from the community and so on with the security angle? Is that a risk?
Yeah, I mean, we actually work quite heavily with the upstream. When we started working with the NSA on this, we really told the NSA that we didn't want them just to throw it over the wall and disappear. So the NSA still has 5 or 6 researchers working on different parts of SELinux, as well as there's a company called Traces that has many engineers working on SELinux. And we have people at IBM, HP, other companies like Trusted Computing Solutions. There's sort of there's a guy named Dominic Grift, who I don't even know who he is, other than he answers SELinux questions all the time, and we work heavily with him. It's like the old, the old joke about you never know who you're working with. It could, on the internet, it could be a dog. There's lots and lots of people. We have a community of testers constantly watching for SELinux errors and SELinux, and they contribute constantly. So yeah, I would say the SELinux community is very much alive and very vibrant. It's a pretty good community to work with.
So if people want to become part of that community and maybe get involved in the development, how do they go about that?
Just basically there's pound SELinux out on IRC. We're out there all the time. You can come. There's 2 mailing lists. There's a Fedora SELinux mailing list. Then there's the developers SELinux mailing list. Just come and join those mailing lists. The code is available if you want to write policy or want to lock down an application. We have tools to do that. You can learn how to write policy. The easiest way is to learn how to write policy, to contribute that way. We have other people that are looking at the actual code, the libraries involved, trying to work with those, and obviously the QA, or the helping us make sure that each Fedora release is running with SELinux well, and contribute that way. But I'm all. Anybody wants to send me a patch or anything, I'll examine the patch and I'll apply it if possible, or get it to upstream, and then we suck in the upstream new developments. So
Sounds
I'm always looking
sounds
for
very
help.
cool. Yeah. I have a question that to be honest, I probably could have looked up the answer to, but I'm far too lazy for that. What license is SELinux actually under then? Is it GPL or how does that work?
Yeah, for the most part, I would call it GPL. There's certain libraries are public domain. There is, again, we're talking about SELinux like it was like there is an SELinux. There is no SELinux. It's a
Right.
it's a rel. Not they take the SELinux. So SELinux is everything from policy to core libraries to kernel features, and some of those have different licensing, but they're either GPL or public domain.
Okay, cool. And I suppose just to kind of bring us towards the wrap up, can you tell us a bit about the future of SELinux? Any new things that are exciting about it that you're working on?
Yeah, I mean, we talked a little bit about sort of the sandboxing stuff and the idea of secure virtualization. We're basically looking, as we move into virtualization, how can we use SELinux to better control what happens to virtualization? What I'm also working on now is networking controls. One of the experiments, a paper I've just written, is talking about can I run a system where I separate out my network in such a way that I say, only these processes can talk to the intranet and these processes can talk to the internet. And so a better explanation would be that, I have certain processes in my computer that talk to Red Hat internal sites for, say, authorization, authentication, and then I have other processes that talk to sort of the general internet. Can I write policy that says that my Firefox can talk to any website? Authorization database can only talk to the LDAP server inside of Red Hat, and that way, if I took my computer system out to a public network somewhere, I can have certain processes that can't communicate at all with any processes but the Red Hat processes. Based on so it's sort of combining IP tables rules to SELinux rules, so we can get sort of again IP tables for processes. Another example of that might be, again, sandboxing. Say I wanted to set up a user for my daughter that she could only go to certain websites. So we could write rules that says that her web browser can go to Nickelodeon, Disney Channel and Barbie.com, and not go to any other sites that I don't know about, and govern that via SELinux instead of sort of having to rely on some kind of third-party proxies and things. And on the same system, I have my Firefox that can go to any site I want. The last use case for that would be around there was an attack last year, and I think it was Firefox Flash plugin, where Flash was allowed to redirect, was following redirect orders from a website. So if you think about, you're inside your private network and you go out to a website, and that website contacts your Flash plugin and tells Flash plugin, hey, go grab data off of, secret.redhat.com on your internal website. A bug in Firefox and Flash allowed that to happen. Now, what I'd like to be able to do is sort of run an internal Firefox and an external Firefox on the same desktop, so that if I'm on the external Firefox, I can't talk to any of my internal sites, and I'm on the internal Firefox, I can't talk to any of the external sites. So if you think about that, I can totally eliminate that type of attack vector, at the web browser level. Now, the ultimate goal there would be to get to put that into tabs. So if I was in a tab and I decided to talk to an internal, say to redhat.com while I'm, on the ESPN.com, it would, open up a new tab. That tab would be isolated from the other tabs. So each one of the processes could get isolated and not be able to, have that cross-contamination. So I'm interested in looking at how we can use these SELinux controls at sort of a network level, or again, combining IP tables and processing, labeling together.
It sounds like there's some really exciting things in the pipeline for SELinux, and Although security, for some reason, some people don't find it a very, I don't know what the word is. I'm going to use it anyway. A very sexy topic. People say it's not very exciting, it's not very sexy, but we all need security. You know, we all need a little security. So I think it's very important that you're doing all this work on it. And I have a couple of quick questions that Randall always likes to ask guests. Some more light-hearted questions, I suppose. But he's a big Emacs advocate, and one of his big questions is always Emacs or VI. So there you go, Emacs or VI.
Definitely Emacs. I'm an old guy.
Definitely Emacs. Cool. Excellent. So thanks very much, Stan, for coming on and talking to us about SELinux. Is there anywhere people can go to get more information? Presumably, I know they can find about it on Red Hat and Fedora and so on. Where should people go if they want to find out?
I mean, I mentioned earlier my blog is at danwalsh.livejournal.com. I'll be giving a 2-hour talk at the Red Hat Summit in Boston in May on writing SELinux policy. I also have a Twitter. I'm rhatdan on Twitter. So if you want to follow me, anybody wants to contact me, dwalsh@redhat.com. I'm also speaking at Linux Tag in May. I'll be in Germany. So anybody in Europe that wants to see me at Linux Tag, I'm giving I think a talk on sandboxing.
Excellent. Sounds good. So thanks very much for joining us, Dan, and we'll speak to you soon.
Okay. Hey, talk to you later. Bye.
Yeah, so a very interesting topic, I thought, actually. Very technical, and I know a few people, when we were talking about this show, were saying to me, how are you going to make this interesting? But I thought that was really fascinating, and I think, as I said, security is a very important topic. I don't know. What do you reckon, Aaron?
Yeah, I think so. Again, I mean, there's all kinds of jokes about it not being sexy and, well, you need protection and all this kind of stuff. But, it is something that's important. And I think that people maybe are starting to forget the days of, Windows 95 and 98 and XP where, those security releases that came out every Tuesday were critical because there was a new virus or something that was infecting your computer on a weekly basis. And in fact, some of the news from last week where, we saw that there was some attempts to hack into WordPress, I believe it was. And the assumption was that it was all based on Windows computers over in Asia, that were running either pirated versions of Windows that hadn't been protected correctly with the latest patches and things. So, I mean, I guess for me, it's something that I've always felt belligerent about, the fact that SELinux was always popping up and when I would install Fedora, and it was kind of a hassle. But in fact, it is something that is good. I mean, why not have another layer of protection on your systems?
Yeah, and that was why I wanted to ask about the home user question, because that is something that I hear a hell of a lot is, what is this and why does it keep popping up and how do I switch it off and so on. But maybe we should make more effort to kind of educate people about what it actually is and why it's there and why they should maybe take notice of when it pops up and tells them that something bad's going on. Yeah,
exactly. Yeah. It's kind of funny because Security Now is coming up, and it kind of would have been nice to get Steve Gibson in on this conversation. It's a little early for him, but it would have been nice to get him involved in the conversation because I'm sure he would have had some interesting points to make as well.
Yeah, definitely, and it would have been interesting to hear what he had to say. But as you say, he's probably still in bed at the moment. No, he's probably not.
He's
a joke.
Yeah.
So next week we've got another show. Randall's back in charge, so you'll be relieved to hear that. That's the 16th of March, Wednesday, the 16th of March. We'll have Michael Yap, who's coming on to talk about yogurt. I think you pronounce that. It's J-O-G. I can't even say the letters. J-O-G-E-T. Yogurt. I'm gonna pronounce that. And apparently, it's an open source workflow management system and process-driven application builder. So that sounds interesting. On March the 23rd, we've got Darren Schreiber. Is coming on to talk to us about 2600 Hertz project, which is a system that helps you to build open source VoIP solutions. I got the 2600 Hertz joke after I visited their website. It's very common in VoIP and so on. And then to round out this quarter of shows this year, we've got Gilad Braca, who's coming on March the 30th to talk about Newspeak. which is a new programming language, apparently, which is in the tradition of self and Smalltalk. And I know Randall's been doing a fair amount of Smalltalk stuff, and he's been getting quite into Smalltalk, so I imagine he'll be interested to talk about that. If you go to twit.tv/floss, you can find a link to the spreadsheet there, the Google spreadsheet, which shows upcoming guests and so on. And if you see a name on, I'm doing what Randall does. If you think there's a name missing from that list that you'd like to get on there, the best thing to do is to contact the project leader and have them email Randall, and his address is merlin@stonehenge.com. That's merlin@stonehenge.com, Merlin with a Y. And if you can get the project leader to email Randall, then that's the best way for them to jump to the top of the ever-growing queue. And as Randall always says, you could do this show almost daily because there's so many open source projects out there. And so, yep, if you think there's something that that we're missing that we need to hear about, then please go and do that. So for myself, coming up, I've been getting into preparations for OggCamp, which is an event that I'm running in the UK with the Linux Outlaws and Ubuntu UK podcast. We did it last year as well. It's an open source kind of barcamp thing, so we'll have more information on that soon. If you go to OggCamp, that's Ogg as in Ogg Vorbis. It's an interesting name. Don't ask where it came from. If you go to oggcamp.org, you can find out more about that. And speaking of events, I'm also organising a gig, a large Creative Commons music gig to do with my Rat Hole Radio music show, which is going to be in Liverpool in the UK on Sunday, April the 24th, which is actually Easter Sunday here in the UK. And I'll be playing along with some other people. We've got loads of great guests coming. If you go to ratholeradio.org/gig, you can find out more about that if you're in the UK and you're near enough to come down. And as always, you can always find out everything that I'm doing at danlynch.org, which is my main address, my main website. And there's links on there to Linux Outlaws and all the other various things that I do. So have a look on there, and you can find Twitter links and identical links and so on. Now, what have you been up to lately, Aaron? I believe you've been to Scale, haven't you?
Yeah, that's right. I was at Scale 2 weekends ago, and Randall and I were both down there and did a podcast from down there. I'm right in the middle of editing now. So hopefully, by this time next week, there'll be a new podcast of The Source out there, which you can find at thesourceshow.org. You can also follow me on Twitter at Aaron Newcomb, or Facebook Aaron Newcomb, or aaronnewcomb.com. So if you can remember my name, you can usually find me on the interwebs.
Yeah, and we talked a little bit about Scale before we started the show today. That's the Southern California Linux Expo, if I've got that name right.
Yep.
It sounds really interesting. Lots of big Linux developers there. Obviously, being in California, it's prime catchment area for that. So lots of cool stuff going on there. Did you see any good talks or any other stuff worth mentioning?
Oh, there's a lot of good talks. I mean, the keynotes were both very good. There was Lee Honeywell was there talking about hackerspaces and how hackerspaces and open source projects have a lot in common and how they kind of help each other out. We also had the CEO of Canonical there during the keynote, which obviously, if you don't know, Ubuntu is the Canonical is the kind of a parent company over the Ubuntu project. So I've got interviews with those folks as well. One of the interesting things about the conference this year is there was a lot of commercial vendors in the expo area, and the reason they were there is because they were hiring, which is really good news, I think, for people in the tech industry and software developers and people involved in open source projects. There's a high degree of interest right now in open source people that work in the open source projects to come on board and work for some of these commercial companies, because they know the caliber of people is quite high. So I was very very interested to see that on the show floor this year.
Yeah, that's great news, obviously, for anyone involved in open source and so on. And it does seem to be a very healthy sector at the moment. I'm completely biased in this, but I have been told by friends in the Silicon Valley area and so on that Linux hiring and open source hiring in general is still very strong. So that's good to know. Excellent. So thanks very much for coming and joining us again, Aaron. Always a pleasure to speak to you.
Anytime.
Yep. Yeah, and we'll keep an eye out for the Source show with all those cool interviews from Scale. So make sure you keep an eye out for that. So we'll see you again for another FLOSS Weekly. Take care.